And so you may begin.
Okay, I want to open homework. Okay, I see that only one student create homework. Am I right?
I'm sorry, I also did the homework, but I wasn't. My laptop isn't here right now, so I wasn't able to submit it, but I did it.
Great. Okay.
I was sick for the whole week, so I couldn't do anything.
Let me 1 minute just to open and to see.
Are you okay now? Is everything okay?
Yeah, I'm better.
Oh, good. Good to hear that.
Ну, окей. Так. Hello, Alexei.
Hello, everyone.
Hello, Alexei. So I think we should start with homework.
Let me get
just
connected.
I just download homework. Okay. I think it's a good idea that you will start with homework. Can you start the discussion, and later I think I can continue.
Oh, me?
Yeah.
Okay, yeah, sure. Yeah, let me okay, that's great. I have just opened the homework. So let me share my screen. Let me share my screen. Okay.
Yeah.
Am I sharing? Yes, I'm sharing. Okay, that's great. So here I see okay, so this is the game of life. Okay, interesting. Okay, good. Yeah, exactly. Okay, very nice. So we see three types of species. So this is species number 1, number 2, and number 3. So we see how to say the most the biggest predator on the in the center, and the predator of number 2 is on the border. Yeah, so it would be great to see some pictures. No artist with labels found. Okay, so let me run this collab code. Okay, do we have something? Oh, by the way, maybe is Daniel is here. Could you please comment on your homework on your? I believe this is your collab, right? So what I have just opened. So this is the game of life with the 3 types of predators. So there are SD, survival, AFG. Okay, yeah, that's good. So could you please comment on what does this
He
mean?
is trying. He is trying, but
Just parses the values and defines it. And the neighbors I changed to return the value of a specified cell. So when you call neighbors, you say level 2 or level 1 and returns. For example, if I say because I named C the level 1 cells, it will return the matrix of C cells nearby.
Okay, so it looks like 3 different layers. So there is
Yeah.
layer C, layer P, and layer Q. So that's actually a 3-dimensional tensors, a 3-dimensional tensor of level 0, 1, 2, 3. So it's like RGB, is it correct?
Yeah.
Okay, good. So what is the meaning of B, S, D, E, F, G?
B is the born rule of level 1, and so S is survival. Same for the D and E for level 2, and F and G for level 3.
Okay, very good. What is the definition of the rule? I see. Here it is.
Yeah.
Okay. Okay. Grass, rabbits, wolves. So, could you please?
I want
Yeah.
to make a graph for this, but I couldn't get to work. So.
Okay, PLT is not defined. Okay, let me help you probably. Matplotlib. So it's working. So its animation is also works. Okay, grass is not defined. What is grass? It's here. Let me download it to the local. And let me open it as a local Jupyter notebook. So NBAG is too complicated. Okay. Okay, it doesn't work. So what's the problem? Axis image is not iteratable. Okay. Okay, what's going on here? Okay, so you want to plot their graphs on good. Okay, so it does happen here. Let us try to do.
I think it's
Okay.
because the animation uses a window or something.
Okay, let's turn off the animation. No, still doesn't work. Okay, let us try to do it locally. Mm-hmm. Oh, it's some old Python. Looks to be 0. Oh, it's update fig. It's update fig. It's update fig. It's update fig. Okay. What is iterate function? Oh, okay. Okay, good. Okay. How many iterations do you have? Okay, 500. Mm-hmm. Nice. Okay, okay. So let me do a stupid. So it will be generation equals to 0. So and generations equals generation this.
Also, you can change in rabbits append to g.p and rules to g.q.
Yeah. So what I just want to look at is the how to say.
Here you have created a mistake. Generation append 2p, not 2. Yes.
Okay, so let's look at the statistics on rabbits, for example.
But you need to change in my code where I put rabbits append to g.c, not g.c, to change it to g.p.
This?
Yes.
And what's about wolves? Wolves about
Q.
wolves? What?
Q.
W?
Q.
Q. Ah. Okay. This?
Yeah.
Okay. Sounds good. Okay. Let's do it in the beautiful way. Okay, and now let us look at the rabbits and wolves. Oh, it is rabbits. Oh, it's rabbits, grass, rabbits, wolves, grass. Okay, Good. Very good. Very good. Yeah, I like it. Okay. Yeah, sounds good. So what's the problem to draw these graphs? Why they're not here? Hello? You may just run one more iteration, or okay. It would be very good. It would be really very good if you can, if you probably know the Doxygen comment style. So when you description B is S is so on returns that sets members or whatever. So just the code without any explanation, it's meh, not so good.
I'll use it next time.
Yes, please. Yeah, it would be really great to have it. Or okay, so this is ChatGPT. Okay, so are you familiar with the open interpreter, or maybe not? Do you know what is it? Open interpreter. Do you know what is it? What is this guy? So this is the how to say? This is the tool that allows to talk to your computer by using natural language. Definitely, it should be done under Docker, only under Docker. Don't do it in bare metal. But with this tool, you can easily create the following stuff. Okay, let me give you an example. Give me an animation. Okay. So let me probably run. Oh, do you see my terminal or no?
Yes, yes.
Terminal, I mean this.
Right now we're seeing
no.
the
No, we
ChatGPT.
don't.
Okay. Okay, so let me stop sharing and let me. So I just want to show you how to use this stuff. So it's not a part of the lecture, but this is the example of. It would be great if you can, if you train doing this. Okay, now I'm screen sharing. So do you see my black terminal?
Now, yes.
Yeah.
Good. Okay. For example, I want Python 3.11. So let me grab some Python to my desktop. I wonder, do I have some? Yeah, we have some. Okay, come on. So slow. Okay. Okay. While this guy is uploading. Yeah, so what I'm encouraging you to do, please never do it on your computer itself. Please do it on Python. So please do it in a Docker. Please do it in the safe environment, because when you allow a neural network or ChatGPT to touch your personal belongings, it may do anything. So it may work with well, it may work in a random way. So
Dockers
please,
can be to you can use virtual machine. Virtual machine is
yes.
much easier than Dockers.
Oh, Probably, yeah, this is, well, I'm convenient with Docker to Docker run -AT minus rm Python 3.11. Okay, here is Python. Okay, so I just want to show you what it is. So let me. So this is what you can do. Give me pip install line for open interpreter. Okay. Okay. This, will it work? Oh yeah, it will. Oh no. Okay, never mind. Not for today. Next time. Anyway. So everything what is being done here, you can definitely ask here. So you see.
And of course, you can ask ChatGPT to check your code.
Yes, exactly. Oh, this is a very good question. Whether you can do it or you cannot do it. Okay, yeah. Let's create.
No, it's a good practice.
Yes, of course, this is a good practice, but I'm encouraging you to use this ChatGPT, Open Interpreter, Copilot, anything. So you are probably not supposed to do everything yourself. So this is a good helper. So please use this helper. Okay, and let me open one more. So yeah, this is the good. Yeah. Sounds good. Sounds very good. Please do the comments. Please do the comments. Yeah. And here append, okay, append works, but NumPy works. It would be better. Okay. Let me open this. Okay. So it's Lotko-Volterra system, as far as I can see. Okay. Yes, very good, very good. Foxes. Okay. Good. Okay, so what about wolves? They're 0?
Yeah, with different values, I got different results. And
So what should
sometimes
be the results for rules will be not 0? I mean, I believe the problem is here, right?
yeah. You can lower the death rate, and I suppose it will survive.
Or death rate of whom?
Wolves.
This works?
Yeah.
Well, actually, I don't think so.
Or increase the birth rate
The same.
when they
Okay,
age.
so let me figure out who is eating whom. So rabbits are being eaten both by foxes and wolves. So foxes are being eaten by wolves, and there's a natural death rate, and this is how this is the condition of birth of one fox. It looks like, yeah. And this is natural death rate of wolves. This is how they eat rabbits, and this is how they eat foxes, right? So it looks like there are no wolves. So let us look at the population of wolves. Okay, let's start with 100 wolves. What's going on with them? Okay, they're dead immediately. So something is problem. Minus g times g, so this is minus g squared. It looks like a bug.
Yeah, you should. I should have put minus g plus g.
I believe this.
You can see the formula up.
Uh-huh.
Minus-
Minus, so this minus g plus h f y. What is f? Rabbit death rate due to the predation of wolves. So, but this is c. C and f is the same?
F is a fox death rate to predation of wolves.
Oh, f is fox death rate.
Yeah.
Yeah?
Yeah.
Okay, so there are three groups of constants. Rabbit death rate due to predation of foxes, and rabbit death rate due to predation of wolves. So A, B, C should be here. A minus B minus C, D, E, F. So what is E? E is fox reproduction, the reproduction rate from eating rabbits. Yes, sounds good. And so just D, E, F, and F is the fox. What is F? Is fox death rate due to predation of wolves. It should be Z here. Not X. It is Z. So here is wolf dynamics. So this is the natural death rate of wolves. H is from foxes. Yes. And I is from rabbits. It should be plus. Because when a wolf eats a rabbit, it doesn't die. It becomes more healthy and fatty and better. So it's a problem to rabbits when foxes are eating them. Or now it's much better, you see? Okay, so this is an exponent decay. Okay, now there are no foxes. Foxes are all dead. Okay, dear ChatGPT, I want Lotka Volterra model with 2 predators, and all should be alive for a long time with oscillations dynamics. Write equations. Give me IPond code and draw the graphs. Okay, go ahead. So you can use ChatGPT as a calculator. Like, I don't know. If you don't know how much is it, 1, 2, 3, 4, 5 times 4, 5, 6, 7, 8. Okay, so yeah. Here it is. For the simplicity, let's extend the Lotko-Volterra model to include 2 predators, denoted as P1 and P2, and 1 prey, X. So X is rabbits, P1 is foxes, and P2 is predation rate coefficient. How in consuming what is B2 are the conversion of fishes consumed prey into new predators. Does it make sense?
But new predator doesn't eat the first one.
Okay. This?
Yeah.
Okay.
And also you can use every language you want, not only English.
Yeah, of course. Well, in English it works kind of. Okay, so this is the system of equations. So this is the death rate of rabbits. So, and rabbits are being eaten only by first predator. Okay. I want also prey to be eaten also by predator 2, P2. So P2 is both X and P1. Change the system. Oh, it's more complexity, so it's become complaining. Come on, go ahead. By the way, guys, so this is the language of LaTeX, and it would be great if you know what is it. LaTeX.
Yeah, we
Okay,
do.
you know it, right? You know this
Yeah,
language.
I worked
Oh,
in
great.
Italy.
That's great. That's great. So actually, all the formals, all the math is usually being written in this language. It is very convenient and very widely used everywhere. So now you can see. So here is the system of 3 equations. So R is it's an interesting. What is it? I believe this is a natural growth. Ah. So I believe ARR, it will give us the explanation. But I believe the R is the natural rate of rabbits. A1 is the death rates of rabbits, and A2 is the death rate of rabbits. Depends on the predator of wolves. So P1 is foxes, P2 is wolves. So this is the dynamics of foxes. So this is a natural death rate of foxes. Yeah. This is this is the natural rate of foxes. This is how one rabbit is being consumed into one fox. So if a mother fox eats 2 rabbits, there is one more fox, little fox. And this is how foxes are being eaten by wolves. By the way, from the equation 1, you may see that there is no natural death of rabbits. So all rabbits, unfortunately, so they're being eaten either by foxes or by wolves. Okay, so and this is P2. So P2 is about wolves. So they are being died by the natural process. They eat rabbits and they eat foxes. Guys, it would be great if you ask me some questions if you don't understand. The question may be, I don't understand anything. What does it mean? Dx over dt or whatever. So I'm waiting for questions. Hello? Am I alone? No, probably. Okay, everyone is silent. Hello, hello.
No, we're here.
Yeah, that's great. Okay,
I
do
mean,
you
it's mostly
understand
fine.
anything what I'm talking about?
Yeah, mostly. I mean, we haven't really formally studied this in school, but the things I'm familiar with, so it's fine.
Okay, that's fun. Okay, so this is the dynamics. Okay, so the modified Lotka-Volterra model. So it gives you all the instructions. Okay, now write the code with long-term oscillation dynamics. Give me IPN code and draw the graphs. So for the next lesson, I will be prepared better with the open interpreter. Definitely, we can use artificial intelligence in the good way. So artificial intelligence is just a helper. This is a tool like a hammer, like a screwdriver, like whatever. So like washing machine, like a car. So it's not a separate organism. So this is just a tool for using. So this is how to use this tool. So please use it. Okay, I've created Jupyter notebook. Okay, give me. Okay.
Sorry, I have one question.
Yes.
What environment are you using to code this? Because for I've been using Visual Studio Code forever, but I've been having some problems lately with compiling, and it just is not working properly. And so I'm looking for an environment to switch to code in, but I'm not really sure what to pick.
Okay, very good question. Are you on Windows or are you on Linux?
Windows.
Okay. I want, this is called Jupyter Notebook. Jupyter Notebook for Python 3.11, how to install on Windows. So ask this guy and it will tell you how to do it.
So just install that to my laptop.
Yes, exactly. Yeah. So the
Oh,
only
okay.
thing you need is just Python notebook. Actually, me personally, I'm not using Windows for the last maybe 15 years. So I have unfortunately no idea how Windows works. Well, I know that this is a popular operation system and many people
Okay.
use it.
No,
Okay,
I've
I
been
don't use it.
using Visual Studio Code because that's what I've started coding with when I was younger, and so I just sort of used it out of habit. And there is like a Jupyter Notebook extension there, so that's what I've been using. But lately, it just hasn't been working properly. So I'm going
Okay.
to just
Well,
install it.
anyway, you can use the Google Collab, so you can do everything in the collaboratory. But this probably may be not so efficient because you have the limitations of RAM and disk and so on. So when running all this stuff locally on your computer, it's probably maybe better. There are pros and cons of using Jupyter Notebook locally or using it on Google Colab. For example, on Google Colab, you can easily upload and download any files from the Google Drive, and doing it locally, it's not as convenient. But locally, so you are the owner, you can do anything. Well, so I would rather recommend to do it locally. Okay, so this is okay. So how to do this on your local computer? You should install Python. You should install, when you have installed Python on your local computer, you just tell pip installer notebook and it will install the Jupyter notebook. So here I may just say Jupyter notebook. Okay, here it is. So, and it opened just, it's opened the browser window and, okay, so this is Python. Let me show you something. Import NumPy as in P, import matplotlib pyplot as plt, x is, I don't know, np array range 100 minus 50. I don't know how to do it in a good way, so let me do it in a bad way. Okay, so okay, very good. So y is x squared. Okay, here y. Here it is. This is a parabola, as you may see. Okay, so Python notebook is just for visualization. So it's also very convenient for writing programs as parts. Yeah, and for example, z is x cube. Yeah, so I want this and this. Come on. Okay, here it is. PLT x slim from 0 to 2. Interesting. What's about XY? Maybe set X slim. Okay. Let's divide it by 1000. Okay. Okay, here it is. So I just want this graph to be more beautiful. Yeah, so now it's better. And PLT grid and whatever. Well, so you can definitely do everything in Wolfram Alpha, but I recommend doing this in Python notebook. Okay, so let's get back here. So yeah. So it wants me this notebook. So let me open it. Here it is. Good. Oh, I don't like it. It created the two predators that are exactly the same. Predator model, you created two predators that are exactly the same. I don't like it. Change the model for the predators to be different. Okay, it's working. It's thinking. So I want the predators to be different. Okay. While this guy is thinking, I wanted to show you so we don't have really too much time, but I really wanted to show you the this. Okay, so this is not the homework. This is something that I have prepared for the today's lesson because it's supposed to be the problem. Okay, so this is the cannonball problem. So it's a ballistic problem. It means that you throw a cannonball and it, well, it flies in the air and it falls down. So this is the notebook and, well, it falls on the ground. Okay, so val is not defined, so and it is not working. Interesting. Fine. Okay. Oh, you see, yeah. Okay, so there is a drag coefficient. So there is a friction with the air. So if I increase the friction coefficient, you can see it becomes this. Okay, there is a problem in this code. This code is with bugs. Let me show you the bug exactly. You see? So there cannot be such trajectory. Yeah. It looks like it goes backward. So starting from here, it goes here. Please look at this code and tell me where is the bug and what should I fix. Does it make sense? Hello? Is anyone here? Or just it's buggy cannonball problem. So it should not work like this. The cannonball doesn't fly like this. So if I set the drag coefficient to whatever 0, it will be just a parabola. Yeah, you can see it. But if the drag coefficient becomes a big number, oh, it becomes very buggy. You see? What's the problem?
Well, I mean, I'm not seeing it right now because I'm on my phone, but I'm assuming that we need to have some sort of
let me make it bigger.
Oh, okay, I see it now. I've zoomed in. I just think we need to make it more precise, like what is the highest number we can have so that it doesn't go backwards.
The problem is that this model does not represent the physics of the process because it looks like when you throw a ball, so the ball is not a boomerang, so it cannot get back to you. So, but the, how to say, the equations looks good, or maybe bad, or maybe good. So look, we go along the time. So we update the acceleration. We calculate the model of the velocity. Oh, by the way, guys, are you familiar with all this stuff? What is acceleration, velocity, coordinate, how they depend on each other? So it's it looks to be okay. Update the velocity Vx, update the velocity Vy. So what I'm actually doing, Vx is the x plus ax times dt. Yeah. So just simple update. But this doesn't work. And the problem, the interesting thing, that the problem is not with physics. The problem is exactly with modeling. So this is physics. It is programming language, Python, and this is how to model the process. So a physicist gives you how it works, the model. The programmer just has written the program, but the guy who is doing mathematical modeling, the modeling of the process, he made a mistake,
Can you
and
print
that's why we
values?
see some weird
Right.
stuff. Okay, where's the problem? Okay,
Daniel,
you
could you
print,
please repeat?
uh,
Yeah.
Can you print values of drag to check if it?
values of drag, of course. Yes, this is a very good idea. Okay, let's do it. So you want to print the values of drag, right?
Yeah.
I can even maybe that would be not the good idea not to print the values of drag, but draw the values of drag. Is it okay?
Yeah.
If I draw them.
Also.
Okay. Let's do it. So drags. Here it will be drags append. Well, actually, this is usually always a good idea when you do mathematical modeling. Instead of printing boring numbers, 1, 2, 3, no, not good. So it's better to draw them, because when you see the graph, you understand something about the graph. For example, when you look at the parabola, you know that the parabola does have either minimum or maximum. But if you just to draw the formula, okay, x squared plus bx plus c equals plus c. Okay, do you know that this graph of this function does have a minimum or maximum? No, you don't know it. But if you draw the picture, you definitely know it. Okay, so let's draw. Okay, so what is t? So it is t, yeah. T append. Okay, so let's do drugs with 0, and I want PLT scatter t drags. Oh, scatter. Here you are. This is drags. So it starts with some big numbers, then it goes low, and then it's becomes this. So you know, when you are working with big numbers, it's probably not a good idea to draw exactly the number, but let's do this. Yeah, logarithmic value. Oh, here it is. Okay, here is the drag. This is the logarithm of the drag.
Well, I suppose it didn't stop at 0. It had some little value that gave velocity increase over time.
But
I
this is
think
but this is actually normal. So, for example, if you set the drag force to be a very low value, it's still the same. It's still approximately the same. And if you let me do this. So xy is the trajectory. Yeah. PLT grid. Yeah, this is a good idea. Okay, so this is the drag. This is the trajectory. Oh, it's, I'm sorry, I did the bad thing. So I had to do the drag force to be small. Okay, here it is. Okay, this is drag force. This is logarithm of the drag force, actually. This is the trajectory. Let's do the exact drag force. It would be kind of the same. Okay, so this is drag force. Drag over time. Here it is. Oh, of course, this is the model of drag, so this is the absolute value of drag. Definitely, the drag will be very small when the velocity is very small, when the speed is small. So at the highest point here, there is only Vx velocity, so the drag force is the lowest value. Well, it's look normal. So let's increase the drag. In 100 times. Okay, here it is. It still looks good, but let me increase one more time. Well, it becomes not so good. The bug in the model somewhere. You see? Yeah, this is a very good idea to draw the drag. Oh, yeah. And it may be better to do this.
This problem is a physicist problem. So just think as physicists. No, try to think like physicists.
Yeah, so this cannot happen.
Yeah.
This is impossible. There is a problem. There is a bug. So I want you to find this bug. This program has bugs. And let me show you. The bugs are here.
Try to find it in physicist. At first, I think.
By the way, do you know where the bug is? So this is, yeah. So this is model parameters. So the mass, the acceleration, initial velocity, angle of the initial velocity, whatever. Yeah. Time step, drag coefficient, drag force. So this is how we calculate the drag force. Yeah, so this is CD times velocity in the power of 2. Okay.
Maybe change the drag first, then the velocity.
Change the drag. How can we change the drag? Okay, I can set it to 0. Or what to do?
No. In the while loop.
It means updating when you update it.
The updating of the drag. So you want to change the line 35, correct?
Yeah.
Okay, how to change it?
To place it before velocity update.
Okay, how should I update this?
Copy it and paste it in line 31.
To line 31?
Yeah.
Here?
Yeah.
Oh, well, it will not work because there's no velocity here. It doesn't know what the velocity is. Let's run it and see the bug, the error. Oh, interesting. It doesn't tell you anything because, okay, velocity was calculated on the previous step. But, well, how to say? Let's stop the kernel and restart and clear output. Kernel ready. You see?
Yeah.
You cannot calculate the drag without calculating the module of velocity. Does that make sense?
Okay, so
So
velocity
drag
is
should
not
be calculated after the
velocity
velocity.
is not defined when we first time enter this cycle, but all other iterations will be defined. So all we needed to do is to just somehow predefine it before the cycle.
Yeah, exactly. Oh,
But
you mean to set up velocity here?
Yeah. So, but
Okay,
you
you're
mean
welcome.
that this was not the error, right?
I don't think so, but we can do it. No. What I can say about this error, this is a very typical error. This is 100% typical error. Okay, yeah, now it works, but we still have this there. Let me do it. Let me do it worst. Let me do it awful.
Try to say about the problem by human language. No, in human language.
Oh, in human language, we have the model. This is the model of the flying ball. This is okay, and it looks like that in this model the ball should come back to me. You see? So it reaches here and then it goes back. So
That's
this
first.
definitely doesn't happen in real life.
That's first
I
step.
have never seen this.
Then just try to understand why. Why
Good
this
question.
happens.
Yeah, why does this happen? What should we also plot? So that was an amazing idea to draw the drag. What can we also draw?
Vx.
Vx. Okay, that's very good. Vx, and it looks like the x is probably has some negative numbers, right? Good, 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 good. Let's draw the x. Here you are. This is Vx. It crosses 0 and it becomes increasing. So it becomes acceleration. What's going on? How it may be? So actually I have this condition when y minus 1 less than 0. It means that when it bounces the ground plane, we stop the simulation. Yeah. So because the ball cannot fly below the ground plane, it just bounces.
Maybe when Yx is under 0, we treat it as it's positive, maybe.
So we should treat it as positive value?
Yeah.
No. No. No, the problem is just a bug. Something is written in the wrong way. Something was forgotten. Let's do the bouncing. So if the ball bounces to
Alexei,
0, yeah.
I'm not sure that the guys are comfortable with going up and down all the time. I mean, is there maybe they need some time just looking at the code without
Yes, so I would
moving the
rather
screen.
want for the guys not just look at the code, but please take the code, explore the code, draw some additional graphs. Okay, for example, this is the graph for Vx. Let me also graph for the y. Okay, so this is the y. There is also, let's draw some graphs for x and y. Whatever, yeah. Or just let's keep the graph for x. So this code is not for watching. This code is for exploring. So print whatever you want. So you can always download the backup. So when you do the mathematical modeling, you're supposed to do the code. When it's like when you're watching soccer on the TV, so you're not supposed to play soccer, you're just watching soccer. The same is there for the mathematical modeling. You should do it manually. You should do it. So then you will be trained. Okay, so let me give this
Will this
notebook.
code
Yeah,
be sent to us?
say again, please.
Is this code going to be sent to us?
Of course it is, yes.
Okay,
So
thanks.
this code will be sent to you. Please do anything what you want is this code, and the homework will be fix this code, make this model work, because definitely this is if I see this, no, this model doesn't work. This mathematical modeling is bad. It's not working. What I can say that this is a very common problem to everything. So you may look at the problem for days, and in some days you found one line, one small line, and say, hey, how it could be so simple, so small, so easy, no problem. Why would I spend, I don't know, 2 hours for this stupid thing? But this stupid thing is a very common thing. So here is the example of the stupid thing that it doesn't work. It gives you some buggy result that definitely is not correct. Yeah, when you set up the drag coefficient to the 0, yeah, so, well, absolutely normal, right? Yeah, no problem. When you set drag coefficient, I don't know, to 1, it becomes, well, not so good. It just not look here, but let me do this. So the problem is with the integration step here, but it's also could be discovered. Okay, so not good, not good. Yeah, let me increase the integration step so you see dot 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 dot. I don't like these dots. I want them to be 10 times more dense. Oh, now it's better. Yeah. Or maybe 100 times more dense. Oh, my computer is struggling. Oh, no, it's okay. That makes sense? Okay, so I want Volodь, could you please share this notebook? I have already shared it in our channel to everyone, and the homework will be: this notebook has a bug. Please find this bug and fix it. Does that make sense?
It's the one you called the buggy cannonball, right?
The buggy cannonball, yes, the buggy
okay,
cannonball notebook. Yeah, let me share with you exactly
Sure.
this notebook. Probably, let's call buggy cannonball. I don't know, new, extended, new, just new. Please share this one, buggy cannonball new, and let me.
Yeah, sure, I'll do that.
Yeah. Let me just find it first of all. Oh, it's okay. So let me prepare this a little bit after the lecture, because I have a trash bin on my computer, so it's impossible to find something good. But okay, so you will be exactly this notebook will be shared for you. Yeah. So please find the bug here. Well, what's the problem? Does that make sense? Please, questions. Do you have any questions?
It's fine. Everything's good.
Very good. So starting from the next lesson, you will be more keen in doing all the stuff. So, and we will be go ahead. And by the way, we still have one technical debt from Daniel that was exactly for the Predator 2 problem. So for the Predator 2 problem, we have actually the problem then when we have this dynamics of one prey and two predators, we have some, oh, there are no foxes or there are no wolves, or so it still narrows down to the problem number one, to the classical Lotka-Volterra problem. So that is great, and this is good that you found out for the game of life the thing that this is a grass, there's a wolves and they are rabbits. Probably Mr. Volodya, could you please explain those guys some stuff from the topology? Because you can see that actually the population of rabbits is exactly on the border of the regions. So there is some, I don't know, sea life, there is some mainland life, and there is some coastal life. So there are guys who are living exactly at the border. So that's why their population is very small. So this is how to say dimension two, and the border has dimension 1. Yeah. So that's
Yeah, I
why
believe
it's
that these concepts, these concepts from topology, they understand without me, without my
okay. That's
help.
great. Yeah. So that's good. Yeah, so that apology. And there will be, okay, and probably the second problem, I will repeat it. Definitely when you are working on the plane, yeah, on the plane, yeah, square, rectangle, whatever. So you have grass, you have wolves, and you have the small and poor foxes on the border. So as you can see in the game of life homework problem. But my question is, what will happen if you add the Predator 3 in the system? So there are, I don't know, rabbits, foxes, wolves, and I don't know, some, I don't know, Darth Vader, something bad, who eats wolves, the predator of human, for example. Well, humans,
A
they
virus.
virus. The viruses. So there should be very special viruses that eats only wolves, and their population depends on the wolves' population. So the population of rabbits depends only on rabbits, wolves, foxes on
Lions or
foxes on
bears.
whom?
Lions or bears.
Okay, bears, whatever. So the interesting thing here is that you can see the topology effect. If you have site 1 and site 2 and the border, and you see that the guys who are surviving at the border and the foxes, the population of foxes is very small. But what will happen if you need the border of a border? What is the border of a border? Definitely you know the answer from the topology, right? So what is the border of the border? What is delta area? Yeah. But it is nice to touch it, to understand it, to have it as a handy tool. But anyway, this is a good thing. This is a more complicated thing. You can definitely extend the dimension of the game of life. It could not either be 2D, but for the 3D game of life, you need this fancy VR device and to have it. Because if you will look at this in the projection, it doesn't work. So it's not beautiful, it's not handy, you can't do this. So you have to have this expensive device. I don't have it, for example. But to do the real 3D modeling, you have to have the 3D stuff to look at 3D. Well, so that's why for now, let's be simple in 2D. So there will be 2 homeworks. Of course, they are 100% optional. If you want to do this, do this. If you don't want to do this, that's okay, no problem. Just for fun. And it would be great if you do it, because it gives you more experience, more some handy stuff. So homework number 1, a buggy cannonball problem. Find the bug, fix it. Problem number 2, add Predator 3 to the Game of Life problem. And for the next lesson, we have a technical depth for the Lotka-Volterra model to make it, to make it work, to make it beautiful, actually to make it more chaotic. Because from physics, you probably know that 3-body problems is a chaotic problems. It has a solution, but solution is an indefinite series. It does not converge. Well, questions? We're exactly at time. Am I correct? Hello, anybody alive here?
No questions from.
Good. Okay, so let me share the homework to Volodya and to Andrei, and please go ahead. Okay. So I believe see you. Oh yeah, guys. It will be not me in a week because I will be off. We have a kind of national holiday here, so everything will be closed. So President's Day in the United States. So sorry. So
next week I will go to Turkey.
Oh, good. So we
Oh, wait.
probably have to miss 1 week, or maybe we will move our lesson maybe to Friday or to some other day. Let's figure it out later, okay? But yeah, I can do definitely, but not in the national holiday because everything will be closed. Well, it's like Christmas, so no man's land. Well, so this
Should
happens
we
here.
skip the next time, or
I don't think
try
so.
to
If it is possible, it would be
shoot it?
better not to skip, but it would be better to move to Friday. But I'm not sure if Friday evening for you is convenient. For me, Friday morning is exactly, it's awesome. It's no problem. But
Well,
if for you,
let's ask
Friday evening
everyone.
is okay, so let's move it to next Friday. So it will be not next Tuesday, but it will be next Friday. Does that make sense?
We'll still be without Andrei because he will be in Turkey during the whole next week. But
I also might not be able to come because I don't live in the town I study in, so I'm usually traveling on Fridays.
Okay, so maybe let's just skip the next stuff because it would be great to have us all together.
yeah,
Sounds good.
okay, deal then.
Okay, yeah. So if we are skipping next, then you have more motivation to do the homework. Just this.
I thought it said more homework.
Well, let's how to say,
No,
you
that I
know,
wasn't
like
suggesting. I wasn't suggesting.
no. Like Chinese people say, you know,
Okay.
they also want the middle way, the middle way. So yeah, not very big, not very small. Do the middle way. Okay.
Okay, thank you.
You're welcome. Okay, it's my pleasure.
So see
Okay,
you all
you.
in
so
2
in
weeks,
2
right?
weeks. So it will be, let me see, it will be February 27th. Okay,
Yeah, that's true.
good.
Okay, see you all, and I'll send you all
I
the
will share the notebook and you will be get prepared for the homework and you have motivation now, probably. Okay, see you. Bye-bye.
Thanks
See
a
you,
lot.
bye.
Thank you. Goodbye.
Yep,
Bye.
welcome.